Good morning, students. So, in today's session, we are going to see the potential due to an electric dipole. Okay, so just before we start, let us just recall. No, electric dipole. We know about the electric dipole. That is a two charges separated by some distances, and different charges are separated by some distances, and you know that net charge means total charge on the electric dipole exists is 0, and the direction of electric dipole is from minus to plus direction. Okay, and this is characterized by the dipole moment, which we know q into 2a, means the magnitude of a charge and distance between them. Then also we have studied about electric field of dipole. We have determined now the electric field of dipole, and what we observed there, we observed there that this magnitude no depends on 1 by r cube and not the 1 by r square. Also, we in the last class we determined about the potential due to the single charge, where it was characterized by 1 by r. Okay, so these things we will keep in mind, and today we are going to calculate the potential due to an electric dipole. So first of all, let us consider an electric dipole. Okay, let us consider an electric dipole. Okay, from here we start to write the statement. Let us consider the dipole AB. Okay, so here's an electric dipole which is separated by some distance to a, okay, a small distance, and we want to calculate the potential due to this dipole at any point P. So here we will try to see in the three cases. The first case, any this random position P. Okay, so as we know, student, know the electric field when we calculated that followed superposition principle, and here also, since electric potential when we say na, so this is the work done by the field, so it will also follow the what superposition principle, means the potential due to this minus charge and this plus charge will be added, right? So what we can say here, the potential due to the dipole is the sum of the potentials due to the charges, that is what q and minus q. You can say plus q and minus q. So we can say that is v is equal to, we will can write now k times what we can say q by r1, okay, and plus kq by r2. Here the charge is minus. See here, this point P is from this dipole axis minus q at our distance r2, and from this positive charge, it is a distance r1. So what we can say that k means, you know that 1 by 4 pi epsilon naught. So q times q1 by r1 plus k minus q by r2. Now what we can take common, q and k, so it will be what, k times q, we can write 1 by r1 minus 1 by r2. Now this, in respect of this position vector, no, r from this middle of the dipole, we can easily determine with the help of some geometry. No, see, for the very small angle, no, as in our consideration, okay, if this r is very very greater than this separation, okay, a, if we suppose r is very very greater than a, then we can calculate, means in the geometry this is very, because we can express it easily, इसलिए हमने इसको इतना वाइड दिखाया है. और अगर ऐसा मान के चलें कि ये दोनों जो चार्जेस हैं, है ना, इसके बीच में बहुत सेपरेशन छोटा है, लाइक दिस, और ये जो पॉइंट ऑफ ऑब्जर्वेशन है ये बहुत दूरी पे है. सो इन दिस रिस्पेक्ट क्या होगा स्टूडेंट्स, दिस विल बी द मिडिल पॉइंट. सो यू कैन सी दैट दिस is very very smaller than this length, है ना. Then we can calculate it easily, है ना. We can compare what is the difference between this length, है ना, by drawing one perpendicular line on this one, and then we can find out the difference and we can relate these two distances. Yes, so from there we can also get the r1 and r2, है ना. तो from the geometry, you know, let us draw a perpendicular BM on this line OP. ठीक है. so क्या हो जाएगा अभी, this, what we can write in terms of this theta, no, this is base, this is perpendicular, this is hypotenuse. So what exactly we can write here, we can here write, let us just do the rough over here to understand. Okay, let us just consider this figure, this cos theta, in this triangle BMO, no, cos theta is equal to what, base by hypotenuse, no. So this is nothing but OM by, what we can write, OB is equal to this, if you see this difference, है ना, this for the long distance, no, अगर ये बहुत ज़्यादा दूरी पे है, so this will be almost same. So this will be what, this complete r minus r1 we can write for this one. Yes, for this OM, what we can write, r minus r1. Now this OB is, you know, A and A, so this is A. What we can write now, that will imply A cos theta is equal to r minus r1, or r1 is equal to, what we can write, r minus A cos theta. Similarly, what we can do, we in this side to calculate the r2, similar way we can increase this. So we can draw a perpendicular line over here, है ना, इस तरीके से. So now this perpendicular, so this is theta, so vertically opposite angle, this will be theta also. So now we can calculate with the help of r2, and similar way when you calculate this thing, है ना, this particular ON, and with reference to this one, then you can get what? R2 is equal to R plus A cos theta. This you will get. Yes, इतना समझ में आ गया? So we can proceed, है ना? So we can substitute the value of R1 and R2 from here. ये कुछ नहीं है, if you calculate the same thing, b cos theta, no, this cos theta actually, okay, इसको नाम दे दो n, तो ये कैलकुलेट हो जाएगा, है ना? एंड देन वैल्यू सब्स्टिट्यूटेड, क्योंकि यहाँ पे ये जो होगा ये r प्लस दिस वैल्यू दैट इज ओ एन, है ना? यू कैन इजिली कैलकुलेट r. So this will be here what? A cos theta. So now substitute the value kq for r1. What we can write? 1 by r minus a cos theta minus 1 by r plus a cos theta. That will imply kq calcium a minus b, a plus b, so a square minus b square, that is a square 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 cos square theta. This will come this side, this will come this side, so this will be r plus a cos theta minus, this will be minus 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 plus a cos theta. So r will cancel out. So what will left here? It will left here k times q is a cos theta 2a cos theta by r square minus a square. So this is the potential at any point p due to this electric dipole. ये हमारा एक्सप्रेशन हो गया. Now the same thing we can change it also. You know, just in the beginning we have discussed in terms of dipole moment, can we express it, this q into 2a? Yes. So what we can write? We can write v is equal to k times what? P cos theta by r square minus a square. Shall we write? Yes. Now as in the beginning we have considered what? R is very greater than A. ये जो R था यहाँ पे तो विजुलाइजेशन करने के लिए हमने R को यहाँ पे कंपैरेटिव में बहुत कम डिफरेंस लग रहा है, बट अगर हम बहुत ज़्यादा डिस्टेंस लेके चले ना तो ये जो A होगा दिस विल बी इननेग्लिजिबल, नो, इन टर्म्स ऑफ दिस A, sorry, R. So what we can say, R is very greater than A, है ना? So therefore what will be there? Cos square theta, sorry, cos square theta. Therefore this a square cos square theta can be neglected in terms of r square. Yes, definitely it can be neglected. So what we can write? V is equal to k p cos theta by r square. One more thing, student, if you notice this figure, no, so this is a displacement vector, no, or sorry, position vector, no. So in terms of this position vector we can represent it. Yes, so it is along the direction of OP. Yes, so we can denote the direction in terms of cos theta. So what we can write? We can write this thing as a kp dot r cap, because in terms of unit vector r cap we can write that which is for the direction. So you know E dot v is equal to what? Av cos theta. So this can be represented as r square. Okay, so this is our final expression for this electric potential due to an electric dipole. Okay, but one thing we have to keep in mind that it is valid only for distance larger, no, in compared to the size of dipole. Yes, compared to the size of dipole. In this case it will be valid only. I hope this thing is clear to you. So this is the whole expression I have drawn. So with this expression we can visualize this thing, no? So this is the whole expression. Now you can take the screenshot of it. Now one more thing, this was our first case, no? So when it was on the this position P, this position P can be on the axial line also, or this position P can be on the equatorial plane also. Yes or no? So in this case, when this will be on the axial line of this electric dipole, what we can say that there can be the two cases, either along the dipole, that is theta will be 0, or opposite of dipole, that is theta will be 180 degree. Now so second case, second case, what we can say that in axial line, okay, the potential on the dipole axis, so what could be there along this, in this direction, along the direction of P we can say. So what it will be in case, that is in case of if theta will be 0, yes, means along the dipole. So in this case what we will get, we will get V is equal to what our formula was, this K P by R square, because cos 0 value will be 1, so that will be along. In the same cases here it will be, if it will be opposite, that is theta is equal to 180 degree. So in this case what will be there, in case of that V will be what, Kp R cos 180 by R square, that is, value will be what, minus, that is minus Kp by R square. So one will be positive, another will be negative. Now third case will be what, suppose it exists in an equatorial plane, the plane containing the perpendicular mid of the dipole. So in this case what will be, that in this case theta will be what, it will become 90 degree. Yes, theta will become 90 degree, and in this case what will be that value, Kp cos theta by R square, that is Kp cos 90 degree. So 90 will be what, 0, means hence net dipole because of equatorial plane will become 0. Okay, that is we can write the potential due to equatorial plane means theta case is 90, therefore V will be 0. So this is the whole expression in case of any point P, in case of on the axis, or in case of equatorial. Okay, so here we have completed the expression for the potential due to an electric dipole. Now we can have a small comparison, students, in basis of the single charge, what we have learned, so we can give our heading what, contrasting feature of electric potential of dipole from that of what, due to a single charge. We can compare it. So directly what we can write here, the potential due to dipole and potential due to what? Single charge. What we have observed, very simple. Here the expression what we got, that is k times cap by r square, and here in the expression what we got, due to the single charge, we simply got k q times of r. Means this expression, what are the differences you are noticing? If you see, this v is directly proportional with dipole moment, yes, whereas this here in the electric potential, it depended on directly what, on the charge. Also what you can see here, this v is inversely proportional with r square, yes, inversely proportional with r square. But in the previous lecture we have observed what, this v was inversely proportional with r only, right? So these are the some differences, means the featuring difference between the electric potential due to a single charge and dipole. So I hope so these things you understood. Okay, see you on next class. Bye for now.